Assalamualaikum. Today we will present how we solve the equation and plot that be given to us. Firstly, I want to introduce to the member of this project. First, the name is Til Kumar, anak lelaki Subramaniam. The metric numbers is B0822101515. Secondly, is me, Muhammad Hakim Ashraf bin Muhammad Kamal, and metric number is B0822102229. And then Muhammad Rashdan bin Muhammad Shamsul B0822102600. Muhammad Syamil Amirul bin Suhairi, and the metric number is B0822102223. At first, I want to present about an introduction. In advanced electrical circuits, transfer function play a vital role in analyzing and understanding the system behavior. A transfer function relates the input and output of linear time invariant system, typically represented as a ratio of polynomials in complex variable S, where S is the Laplace variable. The transfer function provides valuable information about how a circuit or system responds to different input signals in the frequency domain. By examining the transfer functions, engineers can gain insight into key system properties such as stability, frequency response, and damping. Transfer functions are commonly used in various applications, including control systems, signal processing, and circuit analysis. They enable to design and optimize circuits by predicting and manipulating their behavior. By mathematically modeling a circuit using transfer function, engineer can simulate and analyze its performance before implementation, saving time and resource. To obtain the transfer function of an electrical circuit, several techniques can be employed depending on the circuit's capacity. For simpler circuit technique like circuit reduction, nodal analysis, or mesh analysis can be used to derive the transfer function. This method involves applying Kirchhoff's law and solving equation to express the circuit response as a transfer function. The agenda we want to present is first introduction, second methodology, and then method and analysis part A and B, zero and poles, discussion and conclusions. For the method and analysis, we use this shape of the graph for our box plots.
Good morning. My name is Silkma son of Subramaniam from 2BET session 3-1. My metrical number 01D, B0822105515. And now I'm going to explain about the method and analysis of the part A from transfer function to plot plot. So basically we can see that our transfer function equation 4, the equation given are h omega equals to 50 j omega over j omega plus 4 and times with a j omega plus 10 square. And first of all, we need to get the general equation from the equation. So basically from the general equation, we try to simplify the equation to a simpler form. So after we given a transfer function equation, so these are the equation, and we will simplify, derive it with using the general state equation as here, as we got the final result of h omega equals to j omega divided by over 8 times with 1 plus j omega over 4 times with 1 plus j omega over 10 square. And then the next steps will going to be plotting the graph. So we will plot the graph using the magnitude board plot, and then after getting the all the plots, so we will plot the gain graph for the poles and zero. And we will continue with the phase section also. So it will be like two graphs, one is magnitude and one is phase. After the calculation, we getting the final result of from the phase and magnitude. Then we will calculate the gain by determining the magnitude response and a semi-long graph using the frequencies. So, and furthermore, I will be explain the about the graph and about the calculation on the next slide. And based on the phase of board plot, it was derived from a general equation. We determine the phase shift introduced by each other component, transfer function, and sum them up. By resulting, the phase response was plotted on a semi-graph using the frequencies. And zero poles as well, we will see through the denominator from the equation to get the zero and also the poles. So that's all from me. Thank you. So now I'm going to continue my presentation with the equation and the method we have tried to given a solution. So from this assignment, we given that the equation of our question for our transfer function is h omega is equals to 50 j omega over in a bracket j omega plus 4 and close bracket times with in a bracket j omega plus 10 square. So we can see that this is our equation. So our general equation, there is a general equation to make sure that following the general equation to solve this problem. So by using a general equation, we have simplified this problem in the next step. So as followed that 50 j omega over 4 times 1 plus j omega over 4 close bracket times 10 times in a bracket 1 plus j omega over 10 close bracket times 10 times 1 plus j omega over 10. So we can see this is because of we have to make sure that our denominator there is a two brackets. So one is j omega plus 4 and another one is j omega plus 10 square. So the square will be separated into two. So as we can see, there is a separation, so we can separate into two. And the 4 10 the whole number of 4 10 10 is coming out because of we have to make sure that inside the bracket there must be a 1. So we have to make sure that 4 have to make as a 1. So when we make the whole number 4 inside to 1, so we have to take out the 4 as well as 10 also. So when we take out 4 and 10, so it will become 4 over 1 plus j omega over 4, and for 10 10 or in a bracket 1 plus j omega over 10. So this is a solution for that. And after that we have to times out all the numbers. So when we times out all the numbers, we will get 50 j omega over 400 in a bracket 1 plus j omega over 4, and in a bracket open bracket 1 plus j omega over 10 and times with 1 plus j omega over 10. So for the next following equation, so we can see that the 50 and 400, we have to divide it. So when we divide 50 over 4, we can get 1 over 8. So the 8 will be written down in a denominator. So it will be j omega over 8 times 1 plus j omega over 4 and times with 1 plus j omega over 10 close bracket square. So when we took out the 1 over 8, so it will be like j omega 1 over 8 times j omega over 1 plus j omega over 4 and close bracket, then times bracket with 1 plus j omega over 10 square. So we can see here that the general equation, by when we comparing with the general equation, we can see that it looks like we're getting the more lines based on the equation given. So when we from the transfer function given, uh, will change into the magnitude calculation. So when we changes into magnitude calculation, there will be h decibels, hdb. So when we change it, it will become 20 log in a bracket 1 over 8 and plus with 20 log j omega and minus with 20 log 1 plus j omega over 4 and negative 2 times 20 log 1 plus j omega over 10. So because of the fraction inside of the inner bracket, so we will changes into negative 20. So when negative 20s come out, so inside the bracket the fraction will become a whole number, so it will become like to a negative 20 log 20 log 8 plus 20 log j omega minus 20 log 1 plus j omega over 4 and minus with 2 times 20 log 1 plus j omega over 10. So because of the 2 itself in front, because we can see that there is a square for 1 plus j omega over 10. So when the square is written in front, comes in front, so it's like you can see like a differentiation is using over there for the log. And then for the next equation is was the next step is negative 20, all we are timesing in. So negative 20 log 8 plus 20 log j omega minus 20 log 1 plus j omega over 4 and minus 40. When you times 2, when it becomes 40 log 1 plus j omega over 10. So this is we can see this is magnitude equation. So from the magnitude equation we will change the equation into a phase shift equation, which means like we can see from a 20 negative 20 log 8 will becomes positive or negative 0 degree. So for 0 degree there is no positive negative, so we can return as well as a positive or as a negative. And then for the j omega, it will changes into 90 degree and minus with a tangent tan or in a bracket omega over 4 and minus 2 tan omega over 10. So this equation is coming out because of the table has been given. So in a table form, which means like from a transfer function changes into a magnitude and changes in our phase. So there is every equation there is a derivative for every equation from phase to magnitude or phase to transfer function. So this is the equation. So next I will detail about the two graph which has been plotted in a dot plot. So I have stated over there for 4 lines, which is for the 20 log j omega, and also for the 0 and sorry for the 40 log 1 over 1 plus j omega over 10, and also for the 20 log 1 plus over 1 plus j omega over 4, and also the negative 20 log 8. So I will start off with the 20 log j omega. So for the 20 log j omega, its will start point will be from negative 20. So from the negative 20, it will have a straight line. It will be a straight line. So from the straight line, it will touches from a negative 20 to until we can see the end of the graph. So because of the 20, so it start negative 20 and j omega. And then this graph is based on the table that have been represented by my group member just now, and we follow the graph solution for every equation that have been given. So every equation there is a line. So this line started from negative 20 to the end. And then for the second line was start from the 0. It will start from the 0. So from the 0, it will end at the we will take the we will take the point 4. So it's because of 4, it will start at 20, started at a 0. So from the 0 we can see there is a straight line, then cut down the line graph is going down at low point. So it's cutting down at the 4.4, so which means omega at omega 4. So when omega 4 it's going down, and it will be there will be a interception for omega 10 as well. So when the omega 10 line and also omega 4 line, there will be an interception. And because of jw omega 10, so when 10 it cut down at the 10 at the point of omega 10. And then for j omega over 4, so it will cut down at omega 4. And then for 40 log 1 over 1 plus or j omega over 10, so it will reaches until the negative 40 because of a 40 value. Okay, and then same as well as 20 log 1 over 1 plus j omega over 4. And then we can see there is a straight line at the value of 8. So we can see because of why 8, we started from the 0. So from the 0 there will be a calculation until the 20. So we will see the box value. So it's like 2468. Okay, it's like a 2468, and it will cut at there. So it will be a 0 over there. Okay, and it's like nearer to a 20 log. Okay, And then now we will try to explain, try to get it with the gain graph. So from the gain graph, from the first point, we can see that from the first point, we can notice that the first point started at above, on top of negative 40. So because of negative 40, we can notice that the first point for the graph, for the line yellow, it means like the line from 0 to what they call 0 to the 20 of it's cutting down at the j omega 4. So when omega 4, which means like it's 0, for the omega is 0. And then for they call the 20 log negative 20 log 8. So it's like the for the omega, it's 8. The value of hdb is 8. And for omega 4, the value of hdb is 0. And for the uh, 20 log j omega, the hdb is negative 20. So when you plus it all the value, we will get negative 38. So when we get negative 38, so we have to plot the point at above of negative 40. So this is the first point. So then we refer to the second point. So for the second point, the blue line is at 10. So it is why, because of 10, because of we can see at omega 4 it reaches the maximum of 10. So when it reaches the maximum sorry, maximum of 6, so there is be a 6 point. And the next following line is the two zeros that cutting down. So when two zeros are cutting down, we can see that when two zeros are cutting down, so it's cutting down at omega 4 and omega 10. So both are will be 0. So when both are will be 0, and then the straight line will be negative 8, because of the h decibel. So we can see the first line was negative, it's like a negative, it's 6, a negative 6, sorry. And then the two lines are 0 h decibel, and also the another line was negative 8. So when we plus all, it will become negative 2. Sorry, it's negative 2. So it will place at of the bottom of the omega 4. So and then the third point. So the third point is same as well as the second point. So for the third point, the blue line, sorry, not blue line, it's a red line. So for the red line, it will reaches the 10, because of for the 10 graph, it's pointing at it's intercepting at the 10. So it will be 10 or negative or 20. So our calculation, the graph shows 20 and 40. Okay, so 20. And then next was the two lines, which was both 0, one, both are 0. One is 0, another one will be negative 4 for the another line for omega 10. And then another one more line will be 8. So it will remain as a 8 at h decibel. And then the point will be stays as well at bottom of 10, bottom of omega 10 for the magnitude. And for the phase as well, same as well. So there is uh, because of we can't see the graph paper over here, uh, it's too tiny. And let's just refer on a paper. So when we see that it's like a first line on top, it's a 90-degree, okay, and the middle one is a 0-degree, and the third line which intercepting down is a negative 10 omega omega over 4, and another one is a negative 2 uh, negative 2 tan omega over 10. So for the first one, we can see when we changes just now equation into phase, uh, we can see the difference over there, because there is a 0, then plus 90, and then plus with minus with a 10 omega 4, and also minus 2 tan omega 10. So from that, we have plotted the 4 lines graph, and then from the graph, we can notice that uh, for the gain graph, so we will start off with the 90 degree. So from the 90 degree, it will end at the value of 4. After ending at value of 4, it will go down slightly. It will go down slightly at the point sorry 0.4, sorry 0.4, and go down slightly at 1. Okay, and then it uh, for the third point, it will move drastically. It will move drastically to the to intercept at the point of negative 2 tan omega 10, and then it will continues as well with the uh, uh, negative 2 omega 10. So we can see that the 10 omega 4 it's on top, and negative 2 omega 10 it's under 80 degree. It is because it is two times the value of negative 10 omega 4. Okay, and then it's because of its intercept at the uh, sorry 0.4 and 10 sorry 0.4 and a 10, because of omega 4 and omega 10. So after plotting all the graph, so we can notice that uh, there will be a gain graph uh, at the on the board plot. So uh, this all that's all from me, by explaining the both graph for phase and magnitude. So that's all from me. Thank you.
Method and analysis part B. Hi, so here I am going to explain about how from the bot plot we change it into the transfer function. So our query frequency omega equals to 100, and we got 1000 radian per second. So the standard transfer function is hs equal to ks plus z1 and times by s plus z2 and s plus zm over s the power of n, and then we got s plus p1 times by s plus p2, and then we got s plus pq. So the hs will be k times by 1 plus s over z1 and over 1 plus s over p1. So here, when the slope is increased by positive 20 dB per decade, the zeros is present. When slope is decreased by negative 20 dB per decade, so the pulse is present. So here we got omega of 100. So the slope is 20 dB per decade is changing negative 20 dB per decade, and slope is added. So we can simply clarify that the simple pole is exists. So therefore we got 1 plus s over 100 in the denominator. Next we got omega equal to 1000, and then the slope is 0 dB per decade is changing and slope is added. So the simple pole is exists. Therefore 1 plus s over p1 equals to 1 plus s over 1000. So as we can see, we got the 40 log constant line from the 40, and then it constant until 100. So we got negative 20 dB simple pulse line. So it going down from 100 to 1000 omega. So now our transfer function is Ks over 1 plus S over 100 times by 1 plus S over 1000. So we simply solve it, and then we got Ks over 1 over 100 times by 100 plus S times by 1 over 1000 in bracket 1000 plus S. So we simplify it until we got 40 log 40 log 10, and dk is equal to negative 40, and another k is zero point 0.1. So finally we got 10,000 j omega over 100 plus S in bracket and times by 1000 plus S. So we can simply state that the slope of 20 dB from 1000, sorry, from 100 omega radian is going down to 1000 omega. Thank you. Hi, my name is Muhammad Ashdan, and I'm going to explain about zeros and poles. As well known, to determine zeros and poles, we need to look at the transfer function and determine by look at the numerator. So the numerator will be the zeros, and the denominator will be the poles. So to find zeros, we need to equal the terms in numerator to 0 and find the j omega. So in the numerator, we got 50 j omega, and then 50 j omega equals to 0, and then we got j omega equals to 0. So we got two poles, which is one is the simple poles, and we got quadratic poles. So for the simple poles, we got j omega plus 4. Since imaginary component is non-zero, there is no zeros in this function. Thus, there are no zeros in this transfer function. To find poles, equal each terms in denominator to find 0 and find j omega. So for instance, since the power of j omega, which is the simple poles, is 1, then we multiply it with 1. So the multiply is 1. So j omega plus 4 equals to 0, and then we got the j omega equals to negative 4. Furthermore, we know that we got two poles, which is one is simple poles, and then the next one is the quadratic poles. So since the power of j omega plus 10 is 2, and then the multiply is 2, so we can state that this is the quadratic poles, and then we need to do this j omega plus 10 equal to 0, and then we got the j omega is negative 10. Thus poles in this transfer function is negative 4 with multiplicity of 2, and also negative 10 with multiplicity of 2. That's all for me. Thank you.
So, in conclusion, the transfer function is a fundamental tool in advanced electrical circuit analysis. It provides engineers with valuable information about the behavior of a circuit or system in the frequency domain. By examining the transfer function, engineers can gain insight into key properties such as stability, frequency response, and damping. The transfer function allow engineers to analyze the system response to different input signal without explicitly solving differential equation. Moreover, the transfer function help assess the stability of a system by analyzing the location of the poles. Stable systems have all their poles in the left half of the complex plane. The transfer function also provides insight into the damping of a system, indicate whether it is overdamped, critical damp, or underdamped. Overall, the transfer function is a powerful tool that enables engineers to design and optimize advanced electrical circuit by understanding and manipulating their behavior in the frequency domain. It plays a crucial role in circuit analysis, system design, and control system engineering. Thank you.